Okay, a particle P is in equilibrium. So P is either stationary, or if the forces are in equilibrium, P could be moving at a constant speed. So two scenarios there. If you've got a resultant force, then the particle will be accelerating. We'll be looking at using F equals ma in the next example. So given that a particle P is in equilibrium, this is really saying that there is no resultant force. So we can resolve in two perpendicular directions. So for this example, it makes sense to resolve horizontally and vertically. And then if you add the components horizontally, you will get 0. And if you add the components vertically, you will get 0. So if we start by resolving horizontally, I think where to put this on my page, it could be over there. So this is sort of quite common notation for this. I might write in blue. So resolving horizontally. And can you just get into the habit of writing little bits like this down? It really makes it much easier to read. Then we have, you also need to think about positive and negative directions. So for now, we'll take that way as positive and that way as positive. So we've got positive x, positive y. You could change that if you wanted to. So we've got 100 cos 30 plus t cos theta and then this is acting in the negative direction, so it would be minus 140 cos of 45. So I'm using cos for all these because I want the adjacent. We draw in a right angled triangle. So when you add those together, you get 0. What this amounts to, and to be honest, I would look at it this way personally, is that anything acting in this direction, so those two added together are going to have to equal the force acting in the opposite direction. So it's just the same as taking that over to the right hand side. So, doing a good job of smudging my work. We get t cos theta is equal to 140 cos 45 minus 100 cos 30. On your calculators, I'm in the right mode, I think I am, angle unit degrees. Right, on your calculators, can you try and get used to storing these values? So what I want to be doing really is 140 cos 45 minus 100 cos 30. That's going to give me, gives it an exact form actually, minus 50 root 3 plus 70 root 2, or 12.392. You can write down a rounded version, but I would just store that. So I can store that to A by doing store. I'm just coming to the red bit above there, and that's now stored to A. And then similarly, I need to resolve vertically. The only thing I'd say about this question, it's really easy to get a rounding error. So vertically, I've got 140 sine 45, because I'm now wanting the opposite, plus 100 sine 30. That's acting up in that direction, and that needs to equal anything acting down the other way. So that is equal to t sine theta. And so I now have t sine theta, and again putting that into my calculator. So I'm going to do 140 sine 45 plus 100 sine 30. So you could write that as a third, or it's 148.99. But I can literally just store that now. So I'm going to do store, and then there's a little red B there on the top right of that button. So that's now stored to B. And I've got two simultaneous equations, which is kind of what we're expecting to happen, because we've got two unknowns, two equations. And so to eliminate t, I can do 2 divided by 1. Sine theta over cos theta is tan theta. So 2 divided by 1, and just, yeah, communicate. This gives you tan theta is equal to 12.023, although we don't know that yet. So on my calculator now, I want to do the second answer minus the first. I want to do b divided by a, not minus divided by. So to get to b, I do alpha, that gives me b divided by a, and then I've got 12.023081. Don't need to worry about getting a rounding error. And then if I do shift tan answer, I get 85.245, so that's what theta equals. And then we know that t is equal to 12.39 divided by cos of 85.245. And so t is going to equal, so this was my first answer I put in, so that's a divided by cos answer, and we end up with 149.5. If you don't like doing all that faffing around on your calculator, the only other option really is just to write things to quite a few more decimal places than you need, and just check that you don't get an embedded rounding error. So you may even want to give that to 3 sig fig as being 150 newtons. Quite often there's a bit of leeway on a mark scheme, but not always, especially when you're using one answer followed by another, and a few of you have been getting rounding errors in your work. So just have a think about how you're going to tackle that. But yeah, the only other option really is just to write things to more DP. But it is useful to store them in the calculator.